version 2 configurations, and that lets us route traffic for IP version 4 networks. Now in this video, let's consider OSPF version 3. That's going to let us route traffic for IP version 6 networks. And there are a couple of ways to configure OSPF version 3. There's a traditional approach and there's an address families approach. In this video, we're going to look at the traditional approach. And with that approach, we still configure OSPF version 2 as we did before to support IP version 4 networks. And then we add on OSPF version 3 to support IP version 6 networks. Then in our next video, we'll take a look at the address families approach. That's going to allow us to have one routing configuration that performs routing for both IPv4 and for IPv6. But for now, we see this topology has both IP version 4 and IP version 6 networks. Let's begin by configuring OSPF version 2 to support our IP version 4 networks. And we'll begin on router R1. Let's go into global configuration mode, and I'll start the process. I'll say router OSPF process ID 1, and I'll use that shortcut we saw earlier where I want all interfaces to participate in area 0. I'll say network 0.0.0.0.255.255.255.255 area 0. And we're done on router R1. Let's go to router R2. We're not able to use that trick on R2 because we have interfaces in different areas. Let's go into router configuration mode for OSPF process ID 1. And I'm just using one so it's easy to remember. It's not that they have to match between routers. These are locally significant process IDs, not autonomous system numbers. And let's say network 172.16.1.0 and a wildcard mask of 0.0.0.3. That's going to be for gigabit 0/1. We want it to belong to area 0. And then we'll say network 192.168.1.0 0.0.0.3. That's going to be gigabit 0/2. We want it to belong to area 1. Oh, and notice we had an adjacency come up with R1 already. That looks good. And let's do our loopback interface. I'll say network 2.2.2.2 with a wildcard mask of all zeros. We want the loopback interface to also participate in area 1. And we are done with the OSPF version 2 configuration on R2. Let's go to R3, and we'll go into router configuration mode for OSPF process ID 1. And for the gigabit 0/1 network, let's say network 192.168.1.0 and a wildcard mask of 0.0.0.3. We want it to belong to area 1. And for our loopback interface, we'll say network 3.3.3.3 and all zeros wildcard mask. That belongs to area 1. And I wanted to show you something a little bit different here on R3. Rather than giving a network command to say I want to influence an interface to participate in an OSPF process, there's another way to do that. We can go into the interface itself and say, hey, I want you to participate in this OSPF process. Here's how we do that. I'm going to go directly into interface gigabit 0/2. So I'm not going to be giving a network command under router configuration mode to make interface gigabit 0/2 participate. I'm going to go directly into the interface and I'll say IP OSPF process ID 1. I want you to participate in area 1. So we can configure an interface to participate in OSPF using either the network command under router configuration mode or going into the interface itself and saying IP OSPF, give the process ID, area, and give the area number. Now let's make sure that router R3 knows about all the networks in our topology. Let's do a show IP route. And let's see what we know about. We know about the loopback interfaces on all of our routers. That's good. Can I ping the loopback on router R1? Yes, I can. It seems like we do have knowledge of all the different networks in our topology. And at this point, we're able to route IP version 4 networks, but not IP version 6 networks. You'll notice in the topology on screen, we've got IP version 6 configured on these routers as well. Let's use the traditional approach of configuring OSPF version 3 to add the ability to route IP version 6 networks. And we're going to begin, once again, back on router R1. Let's go to R1. And something interesting about IP version 6 routing, and this applies regardless of whether we're using OSPF version. IP version 6 routing, and this applies regardless of whether we're using OSPF version 3, or we're using EIGRP for IPv6, or we're using RIPNG or BGP for IP version 6. Anything that's going to be routing IP version 6 routes, we need to explicitly tell the router that it's got permission. It's allowed to route IP version 6 routes. It's not going to do it by default as it does with our IP version 4 networks. So let's go into global configuration mode, and I'm going to say IPv6 unicast-routing. And something else I like to do as a best practice, I like to turn on Cisco Express forwarding for IP version 6. That makes the forwarding of packets a lot more efficient. I'll say IPv6 CEF for Cisco Express forwarding. Now, let's create the OSPF routing process. Instead of saying router OSPF1, I preface that with IPv6. I'll say IPv6 router OSPF1. Now, in router configuration mode, I could do something like setting the router ID to maybe 1.1.1.1. I might set a couple of passive interfaces. I don't need to send OSPF hellos out of my loopback interface, nor do I need to send OSPF hellos out of gigabit 0/1 because that points out the end stations. But if I give some context-sensitive help, you'll see that there doesn't seem to be a network command here. So how do I make an interface participate in OSPF version 3? Well, remember when we were configuring router R3 a moment ago, and I showed you that you could go directly into an interface to say, hey, I want you to participate in this OSPF version 2 process? That was an option. Well, it's a requirement with OSPF version 3. We must go into the interface to say, I want you to participate in OSPF version 3. So I need to visit each interface. I'll go into interface gigabit 0/1 first, and I'll say IPv6 OSPF process ID 1. I want you to participate in area 0. Let's do that for our other interfaces. Let's go to gigabit 0/2. I'll give the same command. And let's go to our loopback interface, and I'll give the same command there. Now let's go configure routers R2 and R3. Let's move over to router R2, and I'll give just sort of a mirrored configuration here. I'll say IPv6 unicast-routing. Let's enable Cisco Express forwarding for IPv6, and we'll create the routing process. IPv6 router OSPF process ID 1. I'll set the router ID here as well, 2.2.2.2. And let's go into each interface. And let's say I want you to participate in a particular area. And for gigabit 0/1, we're going to be in area 0. I'll say IPv6 OSPF process ID 1. I want you to participate in area 0. Let's go into interface gigabit 0/2. Little typo there. Interface gigabit 0/2. There we go. And I'll say I want you to participate in area 1. And interface loopback 0, I'll say I want you to participate in area 1. One router to go. Let's go over. Oh, by the way, did you notice we had an adjacency come up between R2 and R1? Great. Let's go over to R3, and let's give a similar configuration here. In global configuration mode, I'll say IPv6 unicast-routing, IPv6 CEF, and let's create the routing process. I'll say IPv6 router OSPF process ID 1. Let's set a passive interface. I'll say passive interface gigabit 0/2 and passive interface loopback 0. Let's set the router ID to 3.3.3.3. Then we visit each of the interfaces and tell the interfaces that we want them to participate in this OSPF process. We'll begin on interface gigabit 0/1, and we'll say IPv6 OSPF process ID 1 area 1. Let's go into interface gigabit 0/2, and we'll give the same command. And finally, in our loopback interface, we want it to participate in area 1 as well. And we are done with our configuration, and it looks like we just had an adjacency come up. Awesome. Now let's do some verification. We've already verified that we know IP version 4 networks. What about IP version 6 though? If I do a show IPv6 route, what do we have? Do I know how to get everywhere in the network? Let's see, I seem to. Here's the loopback IP version 6 IP address on R1. Here it is on R2, and here it is. Let's see, I seem to. Here's the loopback IP version 6 IP address on R1. Here it is on R2, and here it is locally. So that looks good. Let's take a look at our neighbors. Let's do a show IPv6 OSPF neighbor command. And I can see that I am a neighbor with R2. Excellent. I can look at a specific interface. I can say show IPv6 OSPF interface gigabit 0/1, and it tells me that on this segment, the designated router is 2.2.2.2, that's R2. My current state is as a BDR, a backup designated router. Let's take a look at our OSPF database. We'll do a show IPv6 OSPF neighbor, or rather database, I meant to type in. And let's take a look at some entries in our OSPF database. This is our link state database. Some of this is going to be somewhat similar to OSPF version 2. Some of it's new. Here we have router link states for area 1. That's like a type 1 LSA for OSPF. Remember, a type 1 LSA is where we're advertising a directly attached network segment. We also have net link states. That's like type 2 LSAs for OSPF version 2. A type 2 LSA is going to be advertised for a network within an area that's a transit network. It's not a stub or anything like that. It's actually connecting to OSPF speaking routers. So it's a transit network, and it's a segment on which a designated router would be elected. So it's not a point-to-point network type. Now we have an inter-area prefix. That's a type 3 LSA that we talked about back in your CCNA studies. That's where we're advertising networks from one area into another area, but the name has changed here with OSPF version 3. Here it's called an inter-area prefix instead of a summary, which I think is better because summary was always sort of a misnomer in my opinion. Now here's something new. We've got type 8 LSAs. What's going on here? Well, type 8 LSAs, that's going to provide information about the IP version 6 addresses on a link, including any link local addresses. We also have intra-area, within an area, intra-area prefixes. These are type 9 LSAs, and they contain information about prefixes for stub networks and transit networks, and they're only sent within an area. And that's a look at the traditional configuration of OSPF version 3.